College Student Mental Health Knowledge Inquiry by Team 5.
Clinical background and introduction. As students transition from the more relaxed environment of high school to the more demanding world of higher education, they may begin to encounter various challenges. Many students experience an increase in mental health issues during their college years. Some of these mental health issues include stress, depression, substance abuse, and anxiety. Specifically, it was found that a significant 11.9% of college students suffer from some sort of anxiety disorder, while another 7 to 9% of college students suffer from depression. Depression is defined as a mood disorder characterized by extreme sadness that persists for days on end. Anxiety is defined as a mental disorder characterized by symptoms of intense and persistent fear, nervousness, and worry. These mental health issues can significantly impact both academic performance and the overall well-being of college students if not controlled or mitigated. Depression can be divided into two categories, bipolar depression and unibipolar depression. These two categories can further be broken down into subtypes. The subtypes of bipolar depression are bipolar 1 disorder and bipolar 2 disorder. Bipolar 1 disorder causes extremes ups and downs in mood and energy, which is why it is sometimes referred to as manic depressive disorder. Bipolar 2 disorder is similar to bipolar 1 disorder. There is still the cycling of ups and downs of mood, yet the ups are less severe than that of bipolar 1, which is referred to as hypomania. The subtypes of unipolar depression include major depressive disorder and dysthymic disorder. Major depressive disorder is diagnosed as persistently low mood, loss of interest in pleasurable activities, lack of energy, sleep disturbances, and/or suicidal thoughts. Dysthymic disorder is a milder, long-lasting form of MDD, which may include symptoms such as lasting sadness, less energy, and insomnia. There are many types of anxiety disorders, such as separation anxiety disorder, social anxiety disorder, panic disorder, agoraphobia, and generalized anxiety disorder. Anxiety can be measured on a spectrum ranging from mild to panic. The first level of anxiety is mild anxiety. Mild anxiety can be managed and does not generally interfere with daily activities. Mild anxiety can be mistaken for shyness or nervousness. The next level of anxiety is moderate anxiety. Moderate anxiety is a slight intense feelings of worry and can lead to difficulty concentrating or sleeping. After moderate anxiety, there is severe anxiety. Severe anxiety is intense and persistent worry and can lead to rapid heart rate and sweating. Panic is the highest level of anxiety. This form of anxiety is characterized by sudden, severe episodes of fear and can cause chest pains and dizziness. Understanding the underlying causes of these mental health issues is crucial. Several factors contribute to the decline in college students' mental well-being, such as psychosocial factors, lifestyle factors, pre-existing conditions, academic stress, and financial struggles. For psychosocial factors, this includes students with poor coping mechanisms, low social interaction, and higher stress levels may be more susceptible to anxiety and depression. For lifestyle factors, lack of physical activity, improper eating habits, and poor sleep quality are all linked to worsening mental health outcomes. For pre-existing conditions, those with a history of mental health issues are usually at a greater risk of worsening symptoms entering college. But regarding academic stress, the pressure of exams, projects, and overall expectations increase symptoms of both anxiety and depression. And finally, financial struggles include financial stressors as well as financial insecurity that can exacerbate issues with mental health.
For the data size and distribution of our data, we had gender, age, course such as the student's major, year of study, cumulative GPA, depression, anxiety, panic attack, and specialist treatment. Of these data points, gender, age, and course were nominal data. Year of study and CGPA are continuous. Depression, anxiety, panic attack, and specialists are binary data. And our total data points is 999.
A logistic regression. So, brief background, it was invented in the 1950s as an alternative to the normal probability density function, and this was inspired through measuring growth in bioassays using logistic functions to model binary outcomes. So why was it created? As I mentioned before, probability functions like the normal ones and the linear regression was inadequate in modeling dependence on a binary outcome, so the logistic model is much more effective at modeling this. And in modern day, logistic regressions are essential in machine learning algorithms for classification. So for applications, we are doing medical research, so obviously like the risk or prevalence of a disease can be predicted by assessing a patient's medical history and other different demographics. But this can also be applied for marketing to analyze whether someone will buy a product or not, in finance to analyze transaction patterns, and socially to develop algorithms to measure voting outcomes. So when it comes to choosing a stat test, the first step is to define your research question, and next is to classify your data types. After that, you want to determine the number of groups or variables you're comparing, make your assumptions, and choose a grade test based off of your sample size. For hypothesis testing, we're going to go over some terminologies. The first is null hypothesis, and this is the hypothesis that we are interested in rejecting. Next, the alternative hypothesis is what we hope to find true. The dependent variable is the outcome being measured, and the independent variable is the variable that is being manipulated. The test statistic is a computed value such as a z-score or t-score, and this helps support or reject our null. And finally, the p-value is the probability of observing a certain statistic. So when do we use this logistic regression? One factor is whether or not the outcome is binary and categorical, and another is whether or not we want to understand relationships between multiple variables and the likelihood of an event occurring. And this means that the dependent variable is bounded between 0 and 1. An example scenario that is similar to our data is assessing the likelihood of anxiety based on gender, GPA, and field of study. Because anxiety is a binary outcome, we'll use the logistic regression to evaluate how these factors influence the odds of experiencing anxiety, and we can use this to model relationships between other variables listed above. The type of data required is the assumption that the dependent variable is binary. And that means that the independent variables have to be either categorical or continuous and not have any strong correlations with each other. And as with most statistical tests, large sample sizes are preferred. Some assumptions are that the dependent variable is binary and the independent variable is categorical or continuous. Observations should be independent and mutually exclusive without multicollinearity. And independent variables should have strong linear relationships with log-og, so this means that it models the logit function. The sample size should be large with no extreme outliers, and the dataset should contain independent observations. Benefits of the logistic regression are that coefficients are easy to interpret, it is fast and well suited for large datasets, it provides probability for predictions, and can be used in a wide variety of fields, and incorporates multiple independent variables. Limitations are assumptions of a linear relationship and unstable coefficients due to difficulty interpreting results, and it requires a careful selection of relevant independent variables. So this may make it underfit and not capture all the complex interactions between variables. So why is the logistic regression the right choice for our data? Our data, especially the bolded categories of depression, anxiety, panic attack, and specialist treatment, are binary data, and so the logistic regression can predict probability of a certain outcome, such as depression, allowing for prevention techniques such as specialist treatment. So, as you can see in the equation on the left, p of x is the probability that the dependent variable equals 1. And if p of x is greater than 0.5, we classify the outcome as occurring or successful. And beta 0 and beta 1 are estimated using the MLE method, and this is similar to the linear regression model that uses least squares. It is important to note that this regression can be hard to calculate by hand because the Taylor series can be used to approximate the MLE. So software implementation. The first step is to import and install all of the packages needed, and after that you can code and start the logistic function as shown. And so example from our data, we were able to code the probability of depression by major, and we were able to list these probabilities and create a graph. So some practical benefits of using Collab is time efficiency, because although Excel is good for running other statistical tests such as linear regressions, ANOVA, and etc., the logistic regression is not actually built into Excel, so you have to install a series of add-ins like real statistics, which can be time-consuming. And by importing packages through several lines of code, the statistical prediction process is much more efficient. In terms of integration, Python is the most common programming language for research in the workforce, and Collab is fully free and has a built-in AI platform to help debug code, making it accessible to users of all skill levels, and is also cloud-based, so it's very easy to collaborate on.
Our second statistical test is the one-way ANOVA. One-way ANOVA was invented in the 1920s and is a credit to Sir Ronald A. Fish, who developed the fundamental idea of variance. In the 1930s, he published the Design of Experiment, which further elaborated on the principles of experimental design and analysis, such as the one-way ANOVA. It was created because it is important and is easy to compare the means of three groups at once, rather than conducting multiple comparison tests such as the t-test. One-way ANOVA offers a structured framework to test null hypothesis that all group means are equal. This allows for identifying where significant differences are if they exist. Fisher developed this method to analyze data from certain experiments more efficiently by summarizing complex data into a single test for overall significance. Now, its applications, there are many different applications of one-way ANOVA, such as the medical and healthcare field, where in clinical trials can be used to evaluate the effectiveness of different treatment drugs by comparing recovery time and based on which treatment is administered. In business, it can be used on things such as advertising and product performance. In advertising, this test can be used to assess the performance of certain marketing campaigns by comparing sales and engagement associated with each campaign. And also in quality control and engineering, it can be used to control the process or improvement. This test can be used to compare efficiency and quality from different manufacturing processes or machines. When would we want to use the one-way ANOVA test? The one-way ANOVA test will show if there is a statistical significance between 3 or more groups on a single variable. It is useful when your groups are independent and unrelated, you have multiple, aka 3 or more groups you wish to test simultaneously, your dependent variable is continuous, and you want to avoid the risk of false positives, such as one that can occur with multiple t-tests. An example scenario is using our data if we want to determine age, course, or GPA have an effect on the prevalence of depression. Since we're comparing 3 independent groups against 1 dependent variable, the one-way ANOVA test is ideal. Thus, we'll use variance between groups and the variance within each group to calculate an F value, which can identify whether or not there's a statistical significance difference between them. What type of data is required? In our 1 independent variable, we need qualitative categorical data and at least 3 distinct groups. In our dependent variable, we need quantitative and numerical data, such as a continuous or ratio data. What are the assumptions of this test? There are 3 assumptions for the one-way ANOVA test. 1, that the data of each group follows a normal distribution. 2, variation within groups should be similar. And 3, the experimental units must be independent both within and between the groups. Now, the benefits of the one-way ANOVA is that it can be used in a wide variety of fields. It's much more time efficient for comparing a large group. It reduces the chance of error, and the F statistic is easy to interpret with the F value table. The limitations of this test are that it assumes the dependent variables are normally distributed. The observational groups must be independent of each other. It can only test 1 dependent variable at a time. There are extreme outliers that can affect the one-way ANOVA test, and the results only tell you if one group is different, but not specifically which one. You need a post hoc test to identify that specific group. In our following example, you would want to determine if 3 airplane wing designs have different effects on the flight distance. You throw each airplane 10 times and record that flight distance. You can compare the differences of multiple airplane designs with the one-way ANOVA test. Now we're going to go through the solution steps on how you would use it in this situation. First is the problem formation. The question is, do the 3 airplane designs have different flight distances? The null hypothesis is that no, there is not a difference in their flight distance, and the alternative hypothesis is that yes, there is a difference. 2. Variable definition assumptions. Our independent variable is the paper airplane design, and the dependent variable is flight distance. We're assuming that the independent variable is nominal and the dependent variable is metric. Each categorical measurement is independent, aka our airplane design does not influence how another one will perform. The distribution is normal within each group so that the flight distances of each design is a normal distribution. The variance of each group and between groups are the same, and their significance value is of 0.05. 3. Mathematical representation. A one-way ANOVA test is calculated by finding the ratio between the variance between groups and the variance within groups. 4. For the procedure, you need to record the flight distances in feet for each airplane. First, you should calculate the overall mean of each group. Here, group A, B, and C means are shown, and then you have your overall mean of all the groups. Next, we will find the sum of squares between each group by adding up all the square differences between the group means and the overall mean. This gives us 146.9. Then you find the sum of squares within each group by adding all the squares of the differences between each value and its group mean. That gives us 97. Then we find the mean squares by dividing each sum of squares by the degrees of freedom. Between the groups, the degree of freedom is groups minus 1. Within the groups, the degree of freedom is the values minus 3. Then, using this, we can calculate our F-score, which would be 20.44, and the corresponding p-value of which must be less than 0.001, which is less than 0.05. So the null hypothesis can be rejected. 5. Interpretation. We rejected the null hypothesis, therefore, paper airplane design has a significant effect on flight distance. There is likely a relationship between these paper airplane designs and flight distance. This analysis tells us that some of these designs likely fly farther than others. Why is the one-way ANOVA test the right choice for interpreting our data? This is for 2 reasons. One is the ability to compare mean differences. This test is ideal for comparing the mean mental health indicators across different categorical groups. And 2, our dataset meets the assumptions of homogeneity of variance. The variance or spread across the dependent variable is similar across all groups being compared because they're large size. Implementation of the one-way ANOVA test into software. The first software we'll be using is Python, and the implementation is very straightforward, as you can upload your data frame as a pandas and code for all the testing you need in Google Colab or Python. The second way is through Excel. Excel is a bit more complicated as you need to go to toolpacks and create add-ons, but you can still have the same result. The reason you want to use one-way ANOVA test with software is for all the same reasons as before, as multiple groups comparison simultaneously, reducing risk of errors, but also most importantly, because you can run your calculations very quickly and make edits if needed. And these are our references.